Welcome to CML InfoTech. My name is Mohammed. Today we're talking about switching from Cisco CCNA, day 7, part 2. Okay, we can understand how the switch will perform. The switching functionality, like you have a switch here. F0/1, F0/3, F0/2. This is the port number of the switch. PC1, PC2, and PC3. So when we connect a PC to the switch, as I said, switch will talk based on MAC address. Okay, so the system will understand the traffic based on the MAC address. But we are sending data between any device by using IP address. Okay, so what is the functionality for expanding the or while communicating the data, like from PC1 to PC2? What we need as per the OSI layer 7, layer 6, layer 5 together, we need a data. On layer 4, the data will travel either via TCP or UDP to address or to check the path, three-way handshaking. From layer 3, it required IP. From layer 2, it required MAC address. Layer 1, it's 01100, something like this. So when you transfer a data, what is needed in order to reach to your destination? You need, if you talk this way, you need data. Of course, then you need layer 4. This is, if you come up, this is from layer 7, 6, 5 together. Layer 4, which is TCP or UDP, will have source port, from which port to destination port, from which port to which port. Example, if you're sending with HTTP, your source port will be 80. This is for the layer 4. Then you need layer 3. What is in layer 3? You need source IP and destination IP. In layer 2, what you need? Source MAC and destination MAC. If PC1 sending to PC2 via switch, so the traffic will go like this. So this is sender, this is receiver. Okay, the sender and receiver for PC1 and PC2, which connected to port number 1 and port number 2, the PC1 will have the MAC address, which is 48-bit binary or 12 hexadigit. Example, I'm going to write the sender MAC address 1111.4.111.4.111.A. This is the MAC address, and here 111.111.111.B. The MAC address. The MAC address will be always unique. Now the sender need IP address, which is 10.0.0.1, and this is 10.0.0.2. Okay. We assign the IP to the system, and system by itself will have the MAC address, and switch always recognize based on MAC address. This is a little bit hot topic regards to switching functionality, required more intention from your end. Okay. Now, how the traffic will flow when you connect a PC or any device to the switch. The PC or the switch or the system, any product doesn't know about others. They are fresh and they are blank. PC1 doesn't know about PC2 or vice versa, or even switch does not know about any device which connected to them. All are blank. So we're starting the communication. Okay. The PC1 wants to send data to PC2. That is our requirement. Okay. Hope you are understanding. Now, we'll talk about 10.0.0.1, 10.0.0.2, 10.0.0.3. This is 11B. I mean 111, 111C. This is 111, 111, 111B. This is MAC. This is IP. This is 111, 111, 111, MAC. You know, the MAC address is the combination of 0 to 9 and A to F. It could be anything. And within the switch, there is a table called MAC table. What do you call it? MAC table within this. Initially, the MAC tables are completely empty, blank. Okay. Within the MAC table, it must have 2 MAC address on every port. 2 MAC address on every port. Example, for the port number F0/1, there is a static MAC. The static MAC helps to address that port is based on layer 2. Okay. That functions is a layer 2, which is called Ethernet technology. The second one is called dynamic MAC within that port. That dynamic MAC is the MAC of the connected device in that port. Example, this F0/1 will have the MAC address, let's say ABCD 111. Okay. And the system connected to that F0/1 will have the different MAC address. So in the MAC table, regards with the F0/1, it contains 2 MAC ABCD1111 AB, then this one. Okay. Initially, the MAC table is empty. So let us see the MAC table. We go to the switch. The command to see the MAC table, show MAC space address table. Now you can see the MAC address table are empty. There is nothing. Okay. Static. Nothing. The static MAC will be defined automatically because of this software tool. It cannot identify, but in every port there could be 2 MAC, one with the static and one with the dynamic. But by going through this command here, you can see nothing. Okay. Now we'll establish the communication from PC1 to PC2. Okay. As I said, from one PC to another PC, it should contain MAC address, IP address, port number, and data minimum. Okay. Now, when a PC1 sends something, the call flow, you need to be more careful about here this area. Okay. The call flow from from PC1 to F0/1, which means to switch. Then from switch to further. So first we're talking about PC1 to F01. The PC1 required source MAC, destination MAC, source IP, destination IP, source port, destination port, and data. Which means if I need to talk to you, someone within your team, I need to know to whom I need to talk. I need to know the destination person name. I need to call the guy to talk. Same way from the PC1, source MAC. Source in the sense, what is the meaning of source? From. Okay. Destination means to. So the PC1 to PC2 means the PC1 sender, which is source, and PC2 is destination. Okay, so the PC1 source MAC. First, what is the source MAC? 111, 111, 111A. Then what is next? Destination MAC. I do not know the destination MAC in the very beginning because the table is empty. In PC1, there is an area, I'll let you know that. So the destination MAC address is empty. So the PC1 need to inform to everybody. So I'm openly talk to you all. Hey, I want to talk to this guy. Is there the guy in this name or yes or no? So maybe I'll check with a person name or something which is equivalent to address that person. But here in the destination MAC, I do not know the destination MAC. So I need to inform to everybody. So here in PC1, talking to PC2, but I do not know PC2. So what I'll do, I'll check with everyone. Everyone in the sense, if this switch is a 24-port switch, I will inform to all the 24 ports. Is there any person or any system, any device having this sort of information? Please reply back. So what is the meaning of to everybody? Everybody, to inform to everyone. That's the code. That's we called broadcast. Broadcast to everyone. What do you mean by everyone? You have a specific network 10.0.0.1 because your traffic generating from 10.0.0.1. When your traffic is generating 10.0.0.1, your traffic will go to everyone within 10 network. Clear? Not to any other network. Maybe you connected some other few devices within the switch having a different network. The traffic will not go to different network. So the 10.0.0.1 traffic will go to everyone means it will go to 10 network broadcast. How do you define the broadcast in one network? If you remember, I said when a host portion is completely turned on, will consider as a broadcast. Let's say 10.0.0.0. In 10.0.0.0, tell me, how do I define a network? Which area will turn on? In 10 network, which is /8, this is network. And this is host. When the host portion is completely turned on, code broadcast, when it completely turned on, this value will become 255. So 10.255.255.255 is the broadcast of .10 network. If I have a system connected to the same switch on a different port, like a port number F07, having IP address 20.0.0.1, this broadcast will not goes to this system because this network is entirely different. For this network, there is a separate broadcast. Hope you understood. So I'm sending information to everyone within that network, which means My system IP is 10.0.0. So the destination MAC, I do not know. Okay. So there is a broadcast, which means to send everyone. Everyone in the sense, this broadcast, you will have layer 3 and layer 2. Okay. The layer 3 is IP, which means if your system IP is 10.0.0.1, 10.0.0.1, the layer 3 broadcast, which is 10.255.255. As an example, if you have a system IP 192.168.10.1, which is classy /24. So this is your network and this is your host. So when the host portion is completely turned on, .255. So this is your host portion. This is called the layer 3 broadcast. Layer 3 broadcast. What is layer 2 broadcast? The layer 2 broadcast in the sense MAC address. You have 12 hexadigit number. This 12 hexadigit number 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is your 12 hexadigit. This could be completely 0 or it could be completely 1. The combination in between them from 0 to 9 and 8 to F. Example, I'm going to start 1, 1, 1, 0, 0, or it could be any value, like for example, A, B, C, D, 1, 2, 3, 4, 5, 6, 7, 8. It could be anything, anything. So let me show you one MAC address in our lab. So if you take the system, PC0, let me take a PC0, command prompt, we can see IP config. That is not working. Okay, here you can see from the switch. Okay, so version. You can see the MAC address. MAC address. You can see 4, 8, 12. So this could be 0 to 9, A to F. Could be anything, any digit. Okay. So that digit should not be completely 0, should not be completely 1. In between any value will be recognized as a MAC address. So now I have a system which has a MAC address, which need to inform to everybody. And this area called layer 2. Layer 2. In layer 2, within MAC address, you need to inform to everyone that I do not know that person, kindly inform. So how do you inform to everyone, which is called completely turned on. This one bit, this is total 48 bit. 48 bit I mentioned in 12 hexa. So the one hexa is equivalent to 4 bits, right? So 4 bits into 12 times, how much? 48. So 4, 4, 4, 4, 4. 16. 16. 16. So total 48. So 4 bits, which is completely turned on, means this called F. The final number within the MAC address. So when I say the layer 3, layer 2 MAC address means completely turned on, FFFFF, FFFFF, then the remaining 4 are F. So your layer 2 destination MAC, as long as you do not know what is the actual MAC address of the destination system, you're going to define to inform everybody. That's called FFF, FFF, FFF. If you know the specific MAC address, that's called unicast. If you does not know, then you're sending to everybody, then called broadcast. So now your destination MAC field is filled. Okay, your source MAC, you know your own MAC address. The destination MAC address, if you do not know, you will put the broadcast to inform to everybody to get the actual MAC address of the destination system. This is called layer 2. Okay, now become layer 3. What's your layer 3? You need a source IP. You know what is your system IP? 10.0.0.1 source IP. Now you need a destination IP. You defined your destination IP, therefore you know the destination IP 10.0.0.2. Then the port number. So the port number based on the service will automatically detect, example, HTTP, it's going to take 80. Now, coming back to the points. Your system ten zero zero one, 10.0.0.2. Your destination MAC address is 11B. This is 11A. F01, F02. Now, what's going on? Source MAC. What do you know? 111A, the last 4 digit. Okay. Destination MAC. You don't know. So that FFFF. Source IP 10.0.0.1. You know the source IP. Destination IP 10.0.0.2. Then port. Then data. Then the port, then data. Okay, so the traffic will go from PC to F0 slash. It will come here. Okay, who will send this data, this information? Okay, the protocol called ARP, Address Resolution Protocol, which is in layer 2. We'll send this traffic to F0 slash 1. Okay, be clear on this area. The moment F0 slash 1 received this data, the first job of the port, once the port has received the data or received any information, that will compare the source info with its MAC table. So here it is a MAC table. Here it is a MAC table. This port will check this. The switch will check. The switch receive the information from port number F0 slash 1. So it will write F0 slash 1. Then it will check, do I have a MAC info of the received system via port number 1 in the MAC table or not? ഒരു സ്വിച്ചിലേക്ക് ഒരു ഡേറ്റ വന്നാൽ, ഒരു any information വന്നാൽ, ആ സ്വിച്ച് അതിന്റെ MAC table വന്ന പോർട്ട് വഴി വന്ന പോർട്ടും എഴുതും, വന്ന പോർട്ട് വഴി വന്ന സോഴ്സ് മാക്കും എഴുതും. ഉണ്ടോ നോക്കും, ഉണ്ടെങ്കിൽ ഒന്നും കൂടെ അപ്ഡേറ്റ് ചെയ്യും, ഇല്ലെങ്കിൽ അത് വീണ്ടും എഴുതും. The moment switch receive the info from any port, that information will be mentioned in the MAC table. So here F0 slash 1 coming via received MAC address Hope you understood. That's the first job. To listen where it is received. The second task of the switch after receive the info to a specific port, where should I send? To whom I send? That is called destination MAC. The switch will never take a decision based on any IP. It always take decision based on MAC. So switch will take whom should I send. So switch will look into the destination MAC table. What the destination MAC says? FFFFF. What is the meaning of FFFF? To send everybody. So the moment the switch understand that needs to send everybody because of FFF in the MAC in the destination MAC field, this will send to everybody, to everyone available, whether the port is having system connected or not. They send to every port within that network. Within that network, like I have a 3 system connected in one network, and I have a 3 more system connected in a 20 network. So this data sending from F0/1 as a broadcast will goes to 1, 2, 3 only. Will never go to example 4, 5, 6 because they are in a different network. Clear? Now, this will goes to every port, F0/3, F0/2. The moment a system or any device connected to that port is received, they will compare the own IP with the destination IP of the received info. Like example, this is 10.0.0.3. This system compared this own IP with the destination IP of the received. We call this as a frame because of layer 2, the received frame. It says 10.0.0.2 minus 10.0.0.3. So this will discard the data, discard the whole info. Come back to F0/2. The F0/2 look into the own IP, which is 10.0.0.2, and checking the destination IP of the received frame 10.0.0.2, it got matched. So the F0/2 will talk back to the F0/1. This try to perform the back. Now, the PC1 sends F0/0. That goes to via broadcast to all the system, including F0/2. Now it's in the F0/2. Talking back from F0/2 to the reverse. So let's see what happened. Now from PC2 to PC1. Okay. Check what is received. Source IP, destination IP, source MAC, destination. Source MAC 11A, destination MAC FFF, destination IP 10.0.0.2, source IP 10.0.0. This what received. Now the PC2 is reverting back. What is source IP? 10.0.0.2. Hope you understand. The source IP, which means I'm talking from PC2, the backwards, source IP. What is destination IP? 10.0.0.1, which is going back to the source system. I mean, this is PC1. Now, source MAC. Source MAC is the MAC of PC2, which is 111B. What is the destination MAC? The destination MAC is PC1 MAC, which received from the incoming frame, which is 11A. So this will go back to PC1, going back to PC1. So the question here, when the PC1 send a frame to PC2, the PC1 does not know the destination MAC, so they put FFF. But now we put the exact MAC because the received frame will have the source MAC 11A. This packet going back from PC2 to PC1 with RARP, reverse ARP. When the reverse ARP content coming from PC2 back to F0/1, F0/2. Sorry. What is the next action? As I said in the very beginning, when something received by the port from the switch, it will check from the port have the correct info, source info. Like for example, PC2 sent to F0/2. So it will write F0/2 own information. Then I check, do I have the MAC of my own port, which I received from the system, which will written as 111, 111, 112. Writing the own info in the switch. What is the next action? Checking the destination information. Destination information. When PC1 sent to F0/1, when it checked the destination info, it says FFF broadcast to everybody. Now coming back to the F0/2, it's checking the destination info, which says that I know the destination info, which is called 1111A. Because 111A is already available in the destination MAC coming from PC2 to PC1. Now, a switch understood that the received frame from PC2 need to send to 111A. Next task of the switch will look, in order to send to 111A, whom I need to send, says send to F0/1. So that traffic will directly populate from PC2 to PC1 because it's not the MAC address, which is called unicast. This port will forward it to the system. The moment PC received complete info, source IP and source MAC, destination IP and the destination MAC address, the switch will store that information in the switch, the PC. I'm coming back from the point. PC2 send F0/2. F0/2 will learn the PC, the source info and look about the destination. The destination info will come to know that send to port number 1 will send via unicast. This port will send to the PC. The moment the PC received, PC will store that info within PC, which is called ARP table. Okay, so I repeat the content once again. The PC1 need to talk to PC2. PC1 will try to populate the frame and inform to the port number 1. As long as PC1 does not know PC2, the PC1 mentioned as a broadcast. Reach to the switch port. The switch will first task will learn the source info, which is from where they came, port number 1, and what is the MAC of the source info. After it's learned, it will send to destination by looking into the destination MAC in the received frame, which says FFF, will inform to everybody, received by everyone, and reject, discard all except the actual info matched. Here in PC2, the destination IP match with 10.0.0.2. So this PC2 will revert back, which is called RARP. That revert information will reach the F0/2. The F0/2 again will learn the source info, which is F0/2 and the MAC 111B. And the F0/2 or the switch will look where it needs to forward. So that's 111A, which will look into the unicast as the info received and forwarded to F0/1 to reach to the F0/1. That will forward it to PC1. Will the PC1 will have the entire info, will add in the ARP table. Now, we'll try to populate one data in the switch. Let me see in the switch table. If you look into this, show MAC address table, nothing. Let me try to ping from PC, 0, command prompt. ping 10.0 to 10.0.01, ping 10.0.03 example. It's pinging ARP minus A is the command to see them. It will happen within nanoseconds. You can see that 10.0.02 destination IP having the MAC address AEC2, which is dynamic. Now you can go back to the switch. Here you can see that dynamically learn the MAC address of the port 1 and 3, which is the different MAC address. And this is default VLAN 1. We'll talk about the VLAN. You just need to understand currently all the ports belongs to single network. Okay, now you can see the MAC table. So here also, let me see ARP. Okay. Fine. We will talk about the ARP later here. Okay, so the summary that when you connected to system, it will be worked through ARP and RARP protocol to learn the MAC address informations. Once the system learn the MAC address, it will be for a short time. Okay, so hope you understand the basic stuff. Okay, so this required a repeated session again. Let me see before any session within this week, inshallah. Hope you understand. Any doubt? Just to connect two systems in a single switch and try understand about how the packet flow comes across. Thank you. Have a good day by understanding the basic code flow within these two switches.